Good morning, madam. My name is Ravindra from CSCD section. Today I am here to talk about the project in data structures, that is implementing a hash map with collision resolution techniques for fast data retrieval in Java. So this is the title of the project, and here we have the project overview. This project focuses on developing a custom hash map in Java with collision resolution techniques. The goal is to implement separate chaining using linked list, allowing efficient data storage and retrieval even in scenarios with hash collisions. So this project is used when the hash table got collision hash table arrives collision. The goal is to implement separate chaining using linked lists, allowing efficient data storage and retrieval even in scenarios with hash collisions. So the objectives of the project is, first one is hash function designing, and next collision handling, and the third one is performance optimization, and next the real world applications and the scalability. First, the hash function design. It develops and tests hash functions to minimize collisions. Collision handling. Implement linked list based collision resolution. Separate chaining. Performance optimization. Ensure fast retrieval time even with large data sets. And next we have the real world applications. Simulate use cases where hash maps optimize system performances. Scalability. Support hash map resizing and rehashing for large scale applications. So these are the objectives we have for the implementation and implementing a hash map with collision resolution techniques for fast data retrieval in Java. And next we have the prerequisites and requirements. The requirements that we have for the project is, first one is Java programming, and the second one is data structures, and the third one is algorithm design, and the fourth one is testing, and the fifth one is user interface. The first one, Java programming. Implement core Java for hashmap development. And the second one is data structures. Use linked list for separate chaining. And the third one is algorithm design. Develop efficient hashing and retrieval algorithms. And the fourth one we have the testing. Simulate high load environment to test hashmap performance. Next is the user interface. Simple console based visualization of hashmap operations. And the technologies that is used for this project is, first one is programming language, Java for core hashmap and linked list implementation. Next, data visualization, console output for tracking hash operations and collision resolution. And the next one is debugging tools, JUnit or similar tools for authorized testing. And next we have the functional components. The functional components are data insertion, implement port method for inserting key value pairs, data retrieval, implement get method to retrieve values by key, collision resolution, use linked list to handle hash collision, data deletion and probability layers. Next, project over workflow, and the project workflow contains the requirement analysis, architecture design, implementation, testing, optimization. And last we have the potential challenges and solutions. The potential challenges and solutions are hash collision, performance bottlenecks, memory usage. Use effective hash functions and separate chaining to minimize data conflicts. Optimize linked list traversal to reduce retrieval time. Memory usage. Dynamically resize hash map to manage large data volumes. So this is the code that we used for the project, and this is the output. And last we have the conclusion. The conclusion, we say that implementing a custom hash map with collision resolution techniques enhances data retrieval efficiency, ensuring reliable and scalable system performance. This project bridges theoretical concepts with practical real world applications in operating systems and software developments. So this is about all about the project of hashing hash map. And next we will see the implementation implementation of the hash mapping. And next we have the project title, and this is all about a overview of the project. This project is nothing but using the linked list in Java to decrease or the resolve the problems of collision in the hashing. So all these objectives and the requirements technologies are used for to solve the collision properties that occur while hashing. So this is all about the project, and next we will see the working of this project, working technique or working process of this project. Thank you, madam.
Hi everyone, welcome to this video where we'll explore how to implement a simple custom hash map in Java. What is hash map? A hash map is a widely used data structure that stores data in key value pairs, offering fast access, insertion, and deletion. Today, we are building our own hash map to better understand how hashing, collisions, and bucket management work under the hood. So let's dive into the code. As you can say the code, first we import java.util list, which is the linked list class, since we use it to manage collisions through chaining. This class is called custom hash map and is generic, meaning it can store key values and values of any type. At the top, we have we define two instance variables where the first one is size, which is set to 16. It determines how many buckets our map will have. After that, we create a table, which is basically an array of linked list, where each index represents a bucket that can hold multiple key value pairs. Next, we have the constructors, where it initializes the table array. Notice that we don't create linked list right away. We create them when needed, which saves memory until keys are actually inserted. Next we have put method. This is our put method. Now let's look at this one, which inserts or updates key value pairs. First, we calculate the index by calling the getIndex key. This uses the hash code of key and the modulo operator to find the correct bucket. If the bucket at this index is empty, we initialize a new linked list. Then we loop through the list to check if the key already exists. If it does, we update the value and return. And if the key does not exist, we add a new code to the list, storing the key and value together. This approach handles collisions by placing multiple entries in the same bucket. After that, the get method, which retrieves a value by key. After calculating the index, we check if a linked list exists at that bucket. So we check using if statement, and if it does, we iterate through the list and return the value if the key value matches. If the key isn't found, then we'll simply return null. This makes retrieval simple and efficient. Moving to next one, which is a remove method. It is a method which deletes a key value pair, basically. It calculates the index, checks for a linked list at that bucket, and removes the node with a matching key. This is done using the remove if method, which simplifies the process. After that, we have hashing. So now let's break the code. Mm, yeah, now let's break down the getIndex method. This one. It generates a bucket index by applying the hash code of the key, taking the modulus with size and returning the absolute value. This keeps this index within bounds of the array. Uh, After that, we have at last we have the main method. where we test the hash map. We insert three key value pairs and retrieve the value for the key 2, this one, and print it. After removing 2, we try to retrieve it again, and the result is null, indicating successful removal. So I'll show you the output. As you can see, this is the output where we have uh, inserted three key value pairs and retrieved the value for the key 2 and printed it. After removing 2, we try to retrieve it again, and the result is null. So this is our code. Uh, so to wrap up, this simple implementation gives you a clear understanding of hash map internals from hashing to collision handling using linked list. Some limitations of this design include the lack of dynamic resizing and more advanced collision strategies like balanced trees. I hope this breakdown helped you understand the core mechanics of hash maps. Thank you for watching and happy coding.